Wonderful. Well, hey, thank you very much for coming out today. I really appreciate your getting up relatively early on a conference day or pre-conference day to come out and listen to the Amazon Developer Day. We just have a couple of housekeeping things to take care of, and for that I'll be talking to you. My name is Mike Hines. Again, glad to have you here. First of all, in the unlikely event of an emergency, please don't try and use your seat cushions as a flotation device. But there are exits back here through which you came. There are also exits right here on the other side of the screen. They may be hard to find, but you can go through those and you'll get straight outside. If you need to use the facilities while you're here, out the doors and to your right, towards the end of the hall, you'll find those. We will be serving a light lunch today, including a vegetarian option, if you so need one. Moscone Center is a non-smoking facility. If you do need to smoke, please go out the doors all the way to your right, and you can go straight on out the doors to the patio there and find ashtrays. Those doors are not locked, so you can come right back in after you finish. I'm told that if you smoke inside, someone may assume that you are on fire, and they will go straight to the emergency section below. Emergencies, please do contact 911. There is a telephone out the doors, again, to your right. Make the first right outside the bank of doors. There you'll find a first aid center, telephone, and an emergency defibrillator device. In the unlikely event one should be needed. All right. Unpleasant stuff aside, we will be making the slides from today's presentation available, or most of the slides from today's presentation available, online after the conference is over. We have all of your email addresses when you scanned in, so do look for an email from us with a location for the slide share for today's presentations. Today's presentations. So we didn't actually theme this. We didn't brand it with a theme or a title. But if we were going to have a theme for today's presentation, it might be how to be a more profitable games developer. Because we have topics that are really in line with that, such as designing and architecting a backend for amazing, successful scale, but not actually having to pay for it until you use it. So we'll learn about that from AWS architecture. We also want to help you make better decisions as game developers. So we'll be taking a look at how you can find out what all of your users are doing, when they're doing it, and make decisions about what is happening in real life instead of guessing. We'll learn about that through AWS Game Analytics. We're also going to go ahead and take a look at keeping users in your game and having more sessions per day or per week in your game. I'll show you data later that shows why this is so important to in-app monetization. But certainly, push notifications are a very important part of bringing people back to your game. We're going to show you some really easy ways to do that. For example, just write the backend service once. Not for every device you need to message. We'll show you how to do that with simple notification service and push notifications. During push notifications, we're also going to feed you your meal. Next is something that I'm really excited about. Imagine, you guys know what you can do as far as code is concerned on a super powerful PC. You can get amazing polygons per second. You can do some really fascinating things with big data. You can do all kinds of things that, well, quite frankly, you just can't do on lower powered devices like netbooks or tablets. Until now. We're going to show you with AppStream a real example of some amazing technology I don't think you've ever thought possible on lower powered devices. This is a fantastic demo. I really encourage you to make sure you stay for that. Next, I'll be talking to you about what's working in in-app monetization. Amazon has collected a whole bunch of data from our App Store, and we've taken a look at what the top 50 successful games are doing with in-app monetization that the rest of us aren't doing. I'll be the first to admit my stuff isn't in the top 50. Anyone else in the top 50 here? I might have you come up and help me present. Okay. So when I say the rest of us, that means us. And maybe we can learn something from the top 50 that we want to implement in some of our games. We'll also do a quick look at what in-app advertising is looking like. So now you've got a whole bunch of ideas on things that you might want to do in your game, but I don't just want you to do this randomly. It's really important that you test it. We have some really great examples of A/B testing with a game called Air Patriots and how a mistake actually turned into a rather happy test that they've used to really improve their monetization and user retention. Last, I want to pull this all together by bringing up Kano Apps, a company that has actually taken everything you see above here and wrapped big-scale HTML5 gaming into something really profitable for them, and how they're going to take what they've already written in HTML5, and they're going to submit that to an app store and get considerably more users by being available on tablets. It's a great day. Hopefully there's a lot you'll be taking away from this day. And not to delay any further, I'd like to introduce Nate, who's going to come up and talk about AWS architecture. Nate, come on up. Come on down.
Cool. Thanks, Mike.
There's your cable.
All right, give me a second to do the old switcheroo here. Should plug A into slot B. Okay. All right, cool. Let me just see if this clicker is hooked up. We're having some issues earlier. Cool. All right. So my name is Nate Weiger. Thanks for coming out, everybody. Great to see you. Like Mike said, we got a really cool day. I'm actually going to be talking for basically 2 hours straight, so bear with me if my voice gets a little hoarse at the end. Initially, the way it was supposed to go is we were going to have 2 different speakers talk about it, and then it ended up just being me talking about 2 different topics. So, but actually, I really love this stuff, so I'm glad to be here. A quick background on me. I'm the principal gaming solutions architect for AWS. What that long-winded title means is I actually work with game companies worldwide to help them leverage AWS. And that's my background as well. I actually saw some cool people that I haven't seen in a little while that I used to work with. I was at Sony for many years building online games, launched a number of them on AWS starting in 2008. So I've been working with the platform firsthand for a while. So I hope to share some of my personal experiences with you and also experiences from working with game companies across the board over the past year and a half. So what are some things I'm going to touch on today? So how many of you have used AWS at least somewhat, maybe to play around or experiment? All right, cool, about half of you. So I'm just going to spend about 5-10 minutes at the start ramping up on kind of core AWS value propositions. Why use AWS for games? What are the things that are important? Why do people have success with it, et cetera? And then once we get past that, we'll go deeper and deeper into gaming-specific stuff. So if you're already a veteran at AWS, bear with me for 5-10 minutes while I kind of cover EC2 and S3 and some of the core services, but I want to make sure that we can kind of bring everybody along with us. So we'll cover core backend, as I mentioned. And then I'm going to spend some time on DynamoDB and scaling the data tier and some of the common problems that people run into as they scale their game up to very high user counts. Towards the end, I'm going to talk about actually running multiplayer games on AWS. We recently released the C3 EC2 instance, and that's basically our 3rd generation compute optimized, C for compute, 3 for 3rd generation. It's got some really cool networking features that make it very compelling for multiplayer games, so we'll cover that. And then I'll just talk briefly game analytics. As I mentioned, there's a whole other hour after this, and then there's additional stuff after that as well. So we always have to start out with a gratuitous logo slide, as I call it, all the different people that are using AWS. But I do want to highlight a couple here that I find interesting. So we've got a whole range of people, actually. You've got social game companies, mobile game companies like Supercell, Rovio, obviously hugely successful. But you've also got shops that are run by smaller teams, and even Supercell is actually, their name comes from the fact that they're small cells of people. And they're small teams, maybe 20, 30 people. And if you think about a game of the size of Clash of Clans running with a small team, that's really made possible by AWS, and they're running completely on us. So we've got social and mobile companies, and on the other end of the gamut, you've got AAA console companies like Naughty Dog, Nintendo. And then the MMO space, we've got more and more adoption there. It's very interesting, actually. Red 5 just recently posted a video case study. They're a bunch of guys who used to work at Blizzard, built World of Warcraft for many years, went off, formed a new studio. They built out their MMO architecture for Firefall entirely on AWS. So I'll talk about that. It's a very interesting architecture, kind of next generation, if you will, for lack of a better term. And of course, worldwide also Nexon, another MMO company. So we've really got across the gamut some really interesting stuff going on in AWS. So I want to talk on each of these different kind of use cases. So core value propositions. This is my favorite one personally, or one of my favorite ones. I've really got kind of 1 or 2 that I tend to focus on. But paying as you scale. In a traditional model, when you have to guess at how much capacity you're going to need, you have to buy physical servers. That's on the left side. And no matter how good you are, how many times you've done it, you're always going to miscalculate. It's just buying physical goods, you can only be so correct. So what AWS allows you to do on the right side then is, because it's all programmatic, because it's all API-driven, you can just make requests to spin up and spin down instances on demand. And of course, on the right side is the perfect world marketing slide where you exactly track demand, right? It doesn't quite look like that in real life, but it actually looks pretty close. So this is DevSisters, which is a two-man shop game company out of Korea. They had a game called Cookie Run, which, if you can imagine Temple Run, but with a little gingerbread man and he's eating cookies, it's basically that game, right? Hugely successful, actually. But as I said, it's two-man shop. It was one guy doing the game design and the front-end graphics, and the other guy was doing the programming and the actual in-game gameplay. And as you can see, their game went viral, and over a 24-hour period, it actually scaled up from needing 2 servers to 60 servers and then back down to 2 servers. And this pattern actually happened a couple times. This particular instance was the App Store ran a promotion without telling them, and so their game went hugely successful, and they were asleep, and they didn't even know this was going on. So this is, basically impossible to do in physical servers. That's probably obvious to everybody. But this kind of pattern is not uncommon at all. I see this again and again in the gaming space, where you hit the front page of the App Store or the top 10 or what have you, and being able to leverage AWS in this manner is one of the things that mobile companies in particular are finding particularly compelling. Sorry. The last thing I'll mention in terms of overall thing is we actually have 10 regions worldwide now. Same API set everywhere, so you can start out and say West Coast, East Coast, US, and then you can decide, hey, it turns out your game's getting a little bit of buzz over in Japan, so you can spin up the same resources, same API in Tokyo. It really is a different way of approaching your infrastructure from a historic data center related model where you'd have to call people and figure out somebody to partner, et cetera, et cetera. So this is really powerful, especially in the mobile and social space as well. And CloudFront, which we'll talk about later, that's our CDN. We now have 51 points of presence, faraway places like India and Korea and such. And that's very, very uniquely interesting for distributing assets and doing other stuff like user-generated content, and I'll cover that in a bit. And we're continuously expanding. The most recent of these was China, so we now have a presence in Beijing as well. So with that kind of context, how are game companies like Supercell with Heyday, Clash of Clans, how are they actually using AWS? What are the services that are interesting to them? I want to focus on, to start with, what I kind of call the core game backend. And more game companies, even in the console and the MMO space, are finding that it makes a lot of sense to use HTTP, use stateless APIs as much as possible. So what we're seeing pretty ubiquitously is that game companies are building the core functionality on something that looks a lot like a web app. And what does that look like? So first you start with a region. That's going to be near your users, straightforward. Then you use our Elastic Load Balancer, which is basically HA Proxy as a service, if you will. It's not HA Proxy, but it's a load balancer that actually distributes load across multiple instances. We always recommend that you'd use 2 availability zones for fault tolerance. So in case one availability zone goes down, you can think of availability zones like data centers within a region. In case one goes down, the other one's still up. And then within those availability zones, you spin up EC2 instances, which is our virtualization technology. Again, for those of you who have used AWS before, this is all old news, but just to make sure we're kind of level set. We've got 11 different flavors of OS, Linux, Windows, et cetera, that you can choose to run the app the way that you want to. And then everybody needs a database of some sort. You can't store data without a database. So we have, on the relational side, we have RDS, which is our relational database services. And you can actually run that in multi-AZ mode, which means that it starts up a secondary database and connects it in the secondary AZ. And then last, but certainly not least, I want to talk about S3. S3 is our HTTP-based file storage. And it's basically just an opaque file store. You just put and get files into it up to a terabyte in size, and you can just upload as much data as you want. So it's ideally suited for any of the type of stuff that you think of that's binary data for games. You've got your game assets, user-generated content, even analytics, which we'll talk about a little bit later. And because you can just put or get to S3, user-generated content is one particularly interesting one, because you can download not only stuff that other people have created, but you can also upload your own and then index it in your app tier. So that's kind of your core basis for your main APIs that you talk about, login, friends list, et cetera. How do you actually scale that up? The previous slide is a very inexpensive way to get started. How do you actually turn that into something that can be millions of users? Step one is you leverage auto-scaling, which is the ability to set up metrics which say, if you're using more than, say, 70% of CPU, then add additional instances. If the aggregate drops below, say, 30%, scale them back down. And it's this methodology that DevSisters with Cookie Run that I showed you, with their scaling, this is exactly the mechanism they used. It's very effective for stateless servers, and that's going back to the point I was mentioning about why people are moving more and more to a stateless tier for as much of their functionality as they can. It's because it really enables you to just treat your servers as just kind of all the same and just scale them up and scale them down to go along with your capacity needs. And then I'm not going to talk too much about caching. Actually, if you're interested in caching, I would be glad to talk to you. It's a point that I am particularly interested in. At reInvent in our November conference, I actually gave a whole hour-long session just talking about Redis and Memcache, et cetera. But Elasticache is our managed caching service. For games, probably the most compelling part is Redis that we just released, and we actually just released Redis 2.8.6 support a few days ago. It allows, if you're not familiar with Redis, it's a pretty cool technology. It came out a few years ago. A lot of game companies are using it for real-time sorting of information, leaderboards in real time, et cetera. Elasticache just completely automates that. You could go and spin up an EC2 instance and just install Redis yourself on it, no problem. But what Elasticache does, it takes care of all of that low-level plumbing, similar to relational database services, which I highlighted on the previous slide. It's just an easy way to spin it out. You can always launch your own EC2 instances, install your own version of MySQL, install your own version of Memcache, Redis. Always an option. But Elasticache, like RDS, is just a nice way to automate those parts of the process. And then CloudFront. This is something that's actually quite interesting to me personally nowadays because we just released put support in CloudFront. So historically, what you could do with CloudFront, like any other CDN, is you could put it in front of an S3 bucket. You can also put it in front of a dynamic origin. You could actually put, and many people do this, you could actually put CloudFront kind of in front of that ELB layer to give you caching at the edge. Not as effective with games because games are much more dynamic as opposed to a traditional web application. But on the asset side, your static assets, your game assets, your levels, your map packs, et cetera, sticking those in an S3 bucket makes a lot of sense. CloudFront then, in the traditional CDN sense, you can actually route all of your GET requests through it, and it's got 51 points of presence worldwide. All you do in your game client is you just, rather than getting it directly from S3, you do an HTTP address to CloudFront instead, and you'll get the nearest POP near you, and that'll greatly increase your performance, decrease last mile latency, decrease packet loss, et cetera. But as I mentioned, the really interesting thing to me about CloudFront is we just released put support a little while ago. And what that means is not only can you get files out of CloudFront like other CDNs, but you can actually put them up through CloudFront as well. And what that enables you is if you think about the user-generated content games out there, if you think, which is one game, actually two of them that I was involved with, which were some of my favorite ones to work on, were very heavily user-generated content driven, meaning that people could create their own characters, they could create their own levels, et cetera. So when you think about uploading that content, you need a way for people to actually be able to quickly upload all their binary assets. They upload their metadata through your app tier, but they also need a way to actually upload the actual asset for that level. So what put support lets you do is you can actually put that to CloudFront, which means you'll get very good performance, much better packet loss at especially remote locations, out in India, Korea, et cetera, where they're quite a bit away from kind of central S3 locations. And we'll actually backhaul it from that edge back to S3 for you. So it really is a cool way to overcome those latency problems, especially at the edge. And the API interaction for that is straightforward as well. You just switch out rather than saying put it to S3, you put it to CloudFront, and you don't actually have to change the way you're coding the logic of the game. So with that all said, we talk about DevSisters. And on the last few slides, to me at least when I look at it, it's cool stuff. I've done it quite a few times myself. But there's there's a lot of steps to actually do there. Like when you actually break it down, you're spinning up load balancers, you're spinning up EC2 instances, you're setting up databases, maybe a caching layer, CDN. There's just a lot of moving parts you have to deal with. And if you're a game developer, you don't really have time for all that, for lack of a better term, right? Like you're 2 or 3 guys, especially in a mobile shop or an indie shop, maybe you're 20 guys, still a relatively small group of guys, and you're trying to actually focus on making a great game, and dealing with infrastructure is not your strong suit. Nobody is buying your game because it has an outstanding infrastructure. If it has a bad infrastructure, that'll be a bad user experience, but nobody's buying your game because it's an awesome backend. So I want to talk to you about something that we're seeing to be very popular with mobile game developers, as well as actually console game developers, and that is Elastic Beanstalk. And what that is it's actually our managed container. And it wraps around all of those different services I just outlined. And so what you have to do is you just worry about writing your app server code, and then you can use Git, or you can upload a zip of your code actually through the web console. And we will actually take care of provisioning your load balancer, spinning up your EC2 instances, spinning up an RDS database, et cetera, for you, and actually pushing your code out. The other nice thing about that you get through Elastic Beanstalk is you actually get a web dashboard. It'll show you the current versions of all your different code and where they are. You can roll forward, roll back. Click. And a key feature here that I want to highlight is it's the same performance as if you weren't using Elastic Beanstalk, which is very different than a lot of the other platform services you can find out in the market. A lot of times when you wind up with a container that's a container on top of other things, you pay a certain performance penalty or you pay a premium. Elastic Beanstalk is actually a free service. You only pay for the underlying EC2 instances, databases, et cetera, that you actually use. It's just our way of making it easier for you guys to actually spin up these instances. You still get full root access. You can still log into them just like any other EC2 instance. You can connect via remote desktop if it's on Windows. You can SSH if it's Linux. So you don't lose any functionality. It really is, in my opinion, just a pure win. So if it were me, I'd use it. Like if I was running a game company now, a few years ago this didn't exist, so everybody was doing it by hand. If I was running a game company now, I would absolutely start with Elastic Beanstalk. So if you haven't looked at it, definitely do. If you looked at it a while ago, take another look. We've released a whole bunch of new features recently, like worker tiers, for example, that let you do background processing, just better scaling metrics. So just a lot of functionality that we keep adding into this area. So definitely check it out. So what does that look like graphically? So this is the diagram we were looking at before. So a Beanstalk will actually wrap around that whole centerpiece of the app. So what it'll actually look like to you is you'll just get a container, and you'll just push to that container, and then Beanstalk will actually manage all of that stuff for you. You can directly access it if you want. You're free to do so, as I mentioned, but you don't have to. Like Beanstalk will actually automate that part completely. And then you can add any other services as well that Beanstalk doesn't manage. And again, this is something that's kind of unique about Beanstalk compared to some of the other PaaS, platform as a service offerings, is that you can actually just connect any of the other pieces you would to Beanstalk still. You're not losing any functionality. Beanstalk actually has a built-in piece of functionality called EB extensions for Elastic Beanstalk extensions. And if you've seen at all our CloudFormation template, it's just JSON. What EB extensions actually does is it'll actually let you plug in any arbitrary JSON CloudFormation template, and it can actually spin up these other services as well. Even if you don't want to go to the full automation, you can easily just enter in the connect strings or enter in the domains or other pieces of information and easily allow Beanstalk to interact with those services. So again, it's pretty powerful. You're never is a tough word. One of the things we really strive for is to make it so that you never have to start over. And you'll see that as we go through the slides. The goal is to enable you to keep growing and not reach a point where you're like, oh, well, Beanstalk took me to a certain point, and now I've outgrown it, and now I have to scrap it and start over with native EC2. That's not the goal. And one thing that's really nice about Beanstalk is I do think it hits that. We've also got alternative services that I don't have slides for, but if you're a Chef fan, also take a look at our AWS OpsWorks service, which is essentially managed Chef. Similar, it gives you a nice web dashboard similar to Beanstalk, but it actually is all integrated with Chef. So if you're familiar with the Chef workflow or maybe using it locally, that's another good one to check out. Similar concept. You're not losing anything. You're not in a special sandboxed area of AWS. It's just the way I think of it is a nice macro to wrap around it to simplify the actual deployment steps. And this is an example of the Beanstalk web dashboard I was mentioning, this is what you actually see after you spin up a Beanstalk app. You can go and you can select from, there's Ruby, Python, Node.js, Java, .NET, and PHP. I think that's all. And we're constantly expanding that list as well. But it supports any of those languages right now. You can just go and say, hey, I want a Ruby app, I want a Node.js app, upload your code, and away you go. And this is just from the CLI. By the way, one of the hallmarks of my slides is extremely bad title puns, so more CLI bell. Okay. This is what the Elastic Beanstalk command line looks like if you're a command line guy like I am. Hopefully it makes a little bit of sense at least. The idea is you go to your game, you use our EB client, Elastic Beanstalk. You can init and then start. You edit your little, in this example, Sinatra app. And then at the very end, there's a one-liner git aws.push, which is a special git hook that we provide that will actually push your code out to Beanstalk, initialize the actual pushing out of the code, et cetera. So, as I said, copy and repeat. All right, so Halfbrick is a great game company with Fruit Ninja. Obviously, I'm sure people are familiar with that game, hugely successful. So one of the things they've run into, and a lot of other gaming companies have run into as well, is databases. Databases are the problem, and it's something that probably anyone that's run a game of decent size can tell you is that when you talk about what you're actually going to run into, you can scale your app tier as much as you want. You can add as many game servers as you want. The problem almost always comes back to your database. And so why is that? And the big factor here is that games are notoriously write-heavy. In a typical web application, you have something like 10x reads to writes, meaning that most people are actually consuming content. You have a few people that are uploading videos or publishing blog posts or commenting even if a site has active comments, it's still a fraction of the actual number of people that are just viewing the page and downloading it. So a lot of the caching techniques out there, a lot of the stuff you can find on the web are really designed to help you with very read-heavy sites, and that's just not gaming at all. With gaming, it's basically the exact opposite. It's not uncommon to have a game that's 3 to 5x as many writes versus reads. And at first glance, that almost sounds kind of silly, like why would you write data 5 times faster than you could actually consume it? And there's actually good reasons for that. As I mentioned, caching is limited use. And if you think about the patterns you're doing all of these kinds of little tiny snapshots, right? You're saying, hey, Nate just got to a new level. Nate just unlocked this achievement. Nate just got 1,000 points. Nate just bought this in-app purchase. And you really don't want to lose any of that data. As I'm sure we can all relate to, is if users lose their progress, they become very grumpy very quickly. I'm sure we've all been there. And so you have to actually write that data in basically real time. If you want to ensure that you're not losing data about your players, if you're not losing their progress, you have to just continuously keep writing it. And relational databases like MySQL are just not designed to handle that. They have a whole bunch of extra stuff that comes with a relational database, all of the ACID properties, the transactional stuff, the ability to go roll back and roll forward and set checkpoints, et cetera. And none of that actually is applicable to the case where you're just writing a whole bunch of atomic writes. It doesn't actually buy you anything. All it does is adds a whole bunch of overhead that the database has to do every time you're writing. Click. All right. And in addition to actually the very high frequency of writes, you have to deal with the fact that you have some binary structures in there typically. As I mentioned, you might have big blobs like game assets, but you probably have a whole bunch of little stuff. Maybe you have some bit masks of actual, the stuff that the person has unlocked, et cetera. Those things are just not nice to databases. As a general rule, like anything that is not an integer or a string is just very not nice to databases. If you actually look at the internals of a lot of databases like MySQL, anything over a certain size is actually written out to a separate piece of disk. And so you're actually doing multiple disk writes where you're writing metadata and then writing out the actual data. It just bogs down a relational database in no time flat. And that's the gist of it, is the database very quickly becomes your bottleneck, and that part becomes very red and very hot very quickly. And the challenge with this is that there's not much you can do if you go down this path. If you go down the typical relational database path, what you can do is you can only grow your database to a certain size, right? You can only get so large until you have the 200 gigabyte machine, of memory and the 48 core or whatever, and then before you know it, your database is thousands of dollars a month, and you're still running into limits with it. So the other alternative is to shard your database out. having sharded databases myself, I can tell you this is not fun. There's nobody that's done it that says it's fun. There's nobody out there that's going to tell you, hey, sharding is super cool, you should try it. It's a horrible experience, in my opinion. And the reason why is what you end up doing with the sharding is you actually have to start partitioning apart your users. And there's a couple different approaches. You can either make users sticky and say, okay, you user, your database home is here, and you user, your database home is there. Or you can use consistent hash ring. I talked about this in my caching talk at reInvent, but there's another approach called consistent hashing where you basically pre-shard your key space and then map users to that. Any of these cases, going back to my point I made a few slides ago, is none of this makes your game better. It's just a huge time suck, and you spend all your time managing this database complexity. Nobody's having any fun. And nobody's buying your game because of it. Like, nobody's going to the App Store, right, and saying, wow, this game's awesome. I heard, I read online that they have this really cool consistent hashing structure for their back-end database shards. This is the game I'm going to buy, right? Like, it's never happened. It's never going to happen, right? So the challenge with this is once you go down the database, the relational database path, at some point, you almost inevitably hit this. So if you look at the alternatives out there, there's been a whole bunch of NoSQL alternatives that have entered the space. I'm sure everybody has heard about things like Cassandra, things about Redis, as I mentioned earlier, things like Couchbase. What these all share in common is they actually eschew the kind of traditional relational database transaction, atomicity, et cetera, all of those properties. They say, hey, what we're going to do is we're just going to make it as fast to write a single record as possible. And the way a lot of these implement that, actually, is they do a couple different strategies. One of them is they write a lot of stuff to memory and then flush it to disk, which can be a little bit sketchy if you think about going back to losing progress. There could be a potential of loss there. The other strategy these guys use is just putting certain restrictions on where data is written. Anyway, if you read up on them, you'll see that they're good solutions, but they come with their own level of complexity, is what I'm trying to say. When you talk about deploying stuff like your own Cassandra, like your own MongoDB cluster, great technologies. I'm not trying to criticize them, but you actually have to set up triplets of replica sets. So you still have complexity, but it's kind of in a different format. So what we offer, which we're finding to be hugely popular with game developers for these reasons, is DynamoDB. And what that is it's a NoSQL data store. It's optimized around key value access. It's fully managed. So similar to S3, which I kind of glazed over, S3 you just put and get keys to and from that, and all you have to worry about is just actually putting data in and getting it back out. Dynamo's the same way. You just get an API endpoint. You create a table in there, and you get that endpoint, and then you just put and get data to and from it. You don't have to worry about managing, okay, how is the data sharded, how is it replicated, et cetera. We handle all of that for you. It's designed to be highly available. What we actually do is when you write a piece of data, we actually write it to 2 locations before giving you a successful OK. And we do that in a few milliseconds. And that's actually a different promise than we provide than a lot of the other NoSQL offerings out there. A lot of them do tricks like write it to memory, and so there's a split second that you could lose the data in order to enable throughput. We actually have some pretty cool tech based around sharding, et cetera, where we'll actually write it to 2 locations before we give you an OK. So whenever you get an OK back from DynamoDB, it's actually been persisted to disk. It's very optimized, SSD-based, et cetera. We have some information on the website if you're interested in the technical. And as I mentioned, you just put and get keys from it, and that's all you have to worry about. That's your actual access pattern. Just recently, we released something that I think really expands the scope of what you can do with DynamoDB, and that is secondary indexes. I'm going to talk about this for a couple slides. In a traditional key value store, the challenge has always been, okay, how do you get to data not by the key? So if you're storing, okay, here's Nate's record, and I want to store that he's on this level, and he has this many points, et cetera, right, this much gold. Okay, how do I then sort it by points? How do I say, okay, who has the most points? Well, in the traditional key value store, you can't. So what you have to do is you actually have to write multiple structures where you have to actually write it, okay, here's the data by Nate, and then here's a separate table that's by top scores. And so you wind up into kind of a different set of headache where you have to really think far into the future of all the different ways you want to potentially access your data. And what secondary indexes do is they actually offer that functionality for you where you can define a secondary index on a table and say, okay, in addition to actually indexing it by key value, which we'll always do for you, then you can also set a secondary index on, say, the top score. And I'll go through an example for that in a minute. And what that lets you do is do those advanced queries and say, okay, actually sort this data in different ways. And just wrapping up kind of the DynamoDB, the way it works, It's a provision throughput model, meaning that you actually go in and you provision the amount of reads and writes you want, and that's what you pay for. So you say, OK, I want on this table, I want 500 writes a second, and I want 200 reads a second. That's what you're going to pay for. Again, we take care of all the other stuff managed into the coverage. You don't have to worry about backups, et cetera. You just pay for the amount of throughput you provision. And the last thing I'll highlight, I didn't put a link in here because I forgot, but there's an open source toolkit out there that you can find very easily. I think we link it off our blog, actually, where somebody has written an actual tool that goes and it looks at the amount of throughput you're actually, looks at our monitoring metrics that we provide via CloudWatch. It actually looks at the amount of throughput you're actively using in Dynamo right now and how much you've provisioned, and it'll actually tweak it on the fly. So in the same way that you can auto-scale and up and down your app server tier, you can actually auto-scale up and down your DynamoDB tier. And that solves the two big things, which is not overpaying for capacity. Of course, you're just paying for what you use. And then if you do have a spike, then it can actually track that and scale it up for you. So it's actually a really cool tool set. What's that? Oh, sorry, yeah, I believe, and Dave at the back can correct me, I believe it's dynamic DynamoDB, is that right? Yes, all right, thumbs up. Dynamic DynamoDB, sorry. Yeah. And so kind of bringing it all together, going back to our Beanstalk example. So Beanstalk, you can actually wrap around all of this using the EB extensions property that I mentioned of Beanstalk. You can just say, hey, interact with DynamoDB rather than interacting with RDS. And again, you can have Beanstalk actually manage all of this for you. So if it was Nate's game company, like this is what I would start with personally these days. I think it's about as simple as you can get. It's going to match your performance for kind of years to come. And you can always add other things to it. That's the real, I think, compelling thing about going with this architecture is you can keep scaling out that middle tier. You can keep scaling out the reads and writes you need from DynamoDB. CloudFront, the CDN, is going to keep scaling with you, especially as we continue to add pop locations. So it's a really simple yet very effective architecture for games. So talking about secondary indexes, I do want to spend a little bit of time on that. So this is a very simple example of a leaderboard in DynamoDB. It's kind of the canonical example everybody can relate to. We actually have this in our documentation, and we actually go into quite a bit of detail on it, which is cool. We see a lot of game companies using DynamoDB, so we're really trying to provide as many use cases to help you guys as possible. So the way DynamoDB tables are structured is there's always a hash key, which is your main key, your primary key, for lack of a better term. That's the hash key. And then on a given, in this example, that's the user ID, right? So just that could be a number, or maybe it can be just a person's name. And then you have the ability to define an optional range key, which is kind of like a sub key, if you will. You don't have to define a range key, but in some situations it makes sense. So in our leaderboard example, we call it game title, but I think a better way to think about it is like level. Like, okay, here's the user's score on this level, level 1, level 2. You can think of those as all different levels. So if you wanted to say, hey, how did Nate do actually on level 2, you would combine those two and say, okay, Nate on level 2, and then you would get my score back. And all the other attributes are unstructured. You don't have to predefine the schema. By default, they're unindexed. So different records you can have different length. In one record, you can have 2 or 3 attributes. The other one, you can have 200. DynamoDB will keep track of all of them for you in terms of being able to let you retrieve them, but it's not going to index them. It's not going to let you be able to actually query by them, at least not in a performant manner. So as I mentioned, how do you actually sort based on top score? So if we want an actual leaderboard and we want to say, okay, on level 1, on Galaxy Invaders, who actually got the best score? How do you do that? Well, that's where secondary indexes come into play. Aha, saw that coming. Okay, so creating a secondary index. What does that actually do? You can actually think of it as just kind of projecting another table. That's more or less what it does. And so what we've done is we've actually pivoted our data now where we've said, okay, we're going to actually set on the secondary index, we want the main hash key to actually be the game title. And then we want the range key to be the top score. So we're taking that same data that we're populating, we're just saying, okay, and now flip it basically on its ear, and we want to access it in a different way. And so now what we can do is we can query combining that hash and range keys. We can query by the actual level, and then the range key is going to be sorted for us. And that's essentially a leaderboard in a nutshell. And again, we have actually a really good write-up on our DynamoDB documentation about this. So I would just go through this. It's in our, if you just go to our actual website and go through DynamoDB and go through the developer guide, there's a set of examples where we actually talk about writing a leaderboard with Dynamo. All right, and just wrapping up on Dynamo, last thing. One of the other things, when you're looking at a new data source, you're like, okay, how do I actually use this? Okay, maybe you're thinking, okay, it sounds kind of cool, but I have limited time. I don't, how do I interact with this? This is a full Python example I threw together. It's not important that you grok the whole thing, but the point is this is actually a complete example. So there's not much code involved. On the left side, that's actually the table definition. You actually only have to do that once. That's actually just creating your table. You could also do that from the web console if you prefer. And on the right side, that's just saving a new score. And then at the bottom right, you just query and you say, hey, the index, use the high scores index. That's the secondary index that we created. And that's all you have to do to actually get your scores out. And for retrieving subsequent records, then you would, for your query, you would actually supply additional parameters. Say, hey, start with record number 10 or the offset, what have you. All right, so I want to switch topics now. So far what we've talked about is building out that your core gaming stack, your core kind of backend that's going to do all of your common functionality. Using REST as much as possible, and if you think about all the requests you're making, they fit that pattern pretty well. If you say, hey, give me a list of games that's currently playing, or give me the high scores list, I want to log in. Log in is a very easy thing to do via REST calls. You just post, and then you get back a session ID. So putting as much of that stuff as possible into your REST tier, and then talked about databases and the importance of actually thinking about your data access patterns. And I want to switch topics actually quite a bit, and I want to talk about EC2, and I want to talk about multiplayer games. So how many of you guys in this room are doing more of a mobile game, more of a kind of a traditional social mobile, maybe a match 3 or something like that? Okay, cool. And then how many of you are looking at like multiplayer, maybe head-to-head or? Okay, cool, great. So, and that's what we're seeing is like more and more people are actually finding that interesting. So there was kind of a gap here where the traditional console PC space obviously became very multiplayer heavy. And then when mobile games first came out, they kind of went back to basics. And they said, OK, here's some basic interactions we're going to offer, a lot of asynchronous gameplay. And now that more and more people are in that, we're seeing more and more real-time play. And even if not real-time, like right now, there's a lot of still interactivity that's going on. You think of games like Clash of Clans, they're actually doing quite a bit of network traffic in order to take care of the whole tower defense aspect. So I want to highlight a couple of recent EC2 offerings. One of them I want to talk about is actually our G2 instance. I'm going to spend literally one slide because we're going to see a presentation later from AppStream. And this is actually our first instance that provides a GPU that you can actually address as a frame buffer. So there's interesting things you can do. Previously, we had an actual GPU on board with our CG1 series that you could use CUDA instructions with, but you couldn't actually do rendering. So there's cool things. First of all, you can do game streaming. I'm not going to talk about that because AppStream is going to cover that, and they've got an awesome demo. But there's other interesting things you can do. You can do like background rendering of assets, maybe as part of like a build process. Say you've got a 3D workflow and you've got to do a whole bunch of assets. Traditionally, you would take all your extra PCs and you throw them in a closet and you'd stick them all together and then have some kind of Perforce script or something that actually stuck them over there. Done it once or twice. So the cool thing about G2 is you can actually do that on the cloud now. You can spin up a bunch of GPUs and you can send off your assets, render them out, save off the output to S3, for example, and then from S3 you can take it basically anywhere you want. You can directly distribute it to end users. You can pull it back in-house as part of your workflow. There's a lot of options there. And as I mentioned, AppStream, and that's all I'm going to talk about because the AppStream presentation is pretty cool. So please stick around for that. I would highly recommend it. So the other instance I want to talk about is our C3 instance, which I mentioned very briefly at the bullets at the start. And what this is our third generation compute optimized. And one of the hallmarks that it really offers is very high packets per second. So before the C3 instance, on a given EC2, excuse me. Sorry. So on a given EC2 instance before C3, you could realistically get a couple 100,000 packets per second. With the C3 now, we've actually done some testing. And you can get over 1 million packets a second, get over 1 million concurrent connections. We don't have any published benchmarks along those lines, but the point being is that it's actually a significant increase over what you could see previously. And along with the actual packets per second rate, you just get very low latency, very low jitter. And there's some reasons for this. I'll go into the next slide. But it's an instance that is very highly optimized around network traffic. So it makes it very interesting if you're talking about multiplayer games, because that's one of the big challenges with multiplayer games, is you're not necessarily sending a lot of data. You're not sending gigs and gigs of data, but you're sending a whole lot of little tiny packets of a few bytes at a time with XY coordinates or little tiny status updates. But you have to send them very quickly. You're using UDP or something, maybe a reliable UDP layer that you wrote on top of it. But the point is, it's very low level, very high packet throughput, and you need very low latency. You don't need a large amount of aggregate bandwidth, but you do need it to be there, and you'd be there quickly. And the C3 instance is our first instance that really delivers on that in a very compelling way. In addition to that aspect, you actually get an Intel Ivy Bridge CPU. You'll also notice on our EC2 instance details page, we're starting to be more and more transparent about the actual CPUs that we're offering in our EC2 instances. A few years ago, when I started using EC2, it was very opaque. There was a lot of talk around ECU and virtual compute units. And what we found over the years is that actually the CPU matters. What version of SSE, what instructions are available, et cetera, matters in a very big way, especially for stuff like gaming. So we're starting to be more and more transparent. And if you go to our EC2 instance details page, and you look down the list, and we've got a whole lot of them to choose from, but in general, if you just stick to the largest one of a given family, so like C3, M3, et cetera, you'll actually see footnotes where we'll actually say, this is this specific type of CPU, this is this specific GPU. If it's on that page, that's actually a guarantee. That says as long as you're actually using this type of instance, that is the type of CPU that's going to be on it. And so it really opens up a lot of possibilities when you talk about stuff that's very demanding on CPU and demanding on network, because you can rely on that from us. SSDs on board. And the way I think about it is these really are built for games. That's one of the key use cases that's driving C3. And it's 15 cents an hour, which is always cool. So how does the actual networking work for the kind of geekier network folks in the room? It's actually a new technology called SR-IOV. It's single root I/O virtualization. And what that means is that's basically hardware virtualized networking. So previously, before this, the before slide, is that the network card would actually come through to the hypervisor, and the hypervisor would have to handle balancing the traffic between all of the different host OSs, all of the different virtual machines running on that actual hypervisor. We put a number of different processes in place and a bunch of tech to do our best effort to actually balancing that, but there's only so much you can do because there's not that native support, and the hypervisor ultimately has to deal with all of the different interrupts. That's one of the things that was a common problem for virtualization, not just for EC2, but virtualization as a whole. I'm sure you've heard about the noisy neighbor problem. A lot of it is network driven. A lot of it is contention because of the level of interrupts that you have for network traffic. Well, that SR-IOV is actually a fundamentally different approach. It actually moves it down into the actual hardware layer, into the device driver layer, and creates these things called virtual functions. I'm not going to spend any more time on that other than just mentioning those. If you really want to read up on it, there's actually some really cool, interesting stuff that Intel has put together in terms of tutorials for how it works. But the point being is that the hardware layer actually on the actual system takes care of the virtualization. So as far as the hypervisor sees, then it's actually a separate network card. So the hypervisor doesn't have to spend any of its time actually switching behind it. It makes a dramatic increase in the amount of packet throughput. Yes?
Is that only available for C3 or across AWS?
Great question. So C3 is our first instance to offer it. Also our R2 instance. Did I get that right, or is it R3? I'm sorry, even our acronyms kind of flow together for me for our EC2. Our I2, I'm sorry, I2. Our I2 instance, which is our new SSD-backed instance, those two both offer it. Future instances, I think you can count on seeing it more and more pervasively, but right now it's on C3 and I2. We do make a note, if you look at that instance details, there's a big giant matrix. And if you see if it says enhanced networking, that's one of the ones that offers it. So that's how you can tell. I would guess, this is my crystal ball guess, that over the next year or two, you're going to see SR-IOV become to be expected. But right now, it's only on the C3 and I2 because they're the most recent instances. We're kind of on the kind of, I don't want to sound cheesy, but it is a bit of the cutting edge. Like it's not like this is pervasive in the industry yet. So we're still kind of at that leading edge of adoption. Oops, wrong button. All right, so how does this affect multiplayer game servers, which is the whole point of this section, right? So you've got your actual Beanstalk app that we already talked about. It's running, it's doing your core stuff like login, etc. But you can't run multiplayer game traffic, UDP traffic, etc. through an HTTP layer. It's just not possible. So what you can do is you can spin up additional sets of servers alongside your Beanstalk app and just give them public IPs. Put them in a security group. Using our terminology, put them in a security group that has public access to the actual internet. Give them a public IP. And just have them live alongside your Beanstalk app. And of course, you can still have CloudFront, and you'll want to have CloudFront along that side to handle your actual assets. So this is the kind of basics, and we're going to spend a few slides on going into it in a little more detail. So you've got your game servers running alongside, running the C3 instance, making a couple notes on C3 I glossed over. This is in our documentation, but you'll have to use HVM, which is hardware virtualized machines, as opposed to older generations of PV, para-virtualized. It's just a flag you set. Make sure to choose the right instance type. And then there's actually a flag where you have to set enhanced networking to true. Again, it's in our documentation, but just a couple details. When you're launching a C3, just make sure you follow those steps. We've got kind of like a 1, 2, 3 step. So assuming you know that, your game server instances will be set up for high-performance networking. On those EC2 instances, then you can run whatever kind of actual game engine you want. If you want to run Unreal on Windows, you can do that. Absolutely, game companies doing that. Obviously, the types of instances you're running between your web tier and your game server tier do not have to match. You could be running a Python on Linux app in your Beanstalk app, and then you could be running Windows with Unreal Engine on your EC2 game server instances. Absolutely see companies doing that. You get kind of the best of both worlds. You're able to horizontally scale out your Beanstalk app, that web tier, and then you're also able to use tools that you're familiar with and have been proven, like Unreal Engine. So what does this look like from a game flow? What does it look like when your actual game goes to connect? So I just put together an example flow just to kind of hit the high-level process to kind of solidify a little bit more. So first step is your game client logs into via your Beanstalk app. Login is a very easy thing to run via REST. It's ubiquitous. You may even be doing login via a third party like Facebook, federated login. We actually offer a federated login plugin, if you will, where if you're using Facebook, Google, or Amazon identity, if you want to use those kind of big three, look up our federated auth. It's just called federated auth. And it's actually a set of calls you can use to delegate login to Facebook, and then you'll get back an actual authentication token that you can use to then authenticate you throughout the rest of the AWS infrastructure. So I won't spend a lot of time on that other than mentioning that, but it's interesting when you talk about stuff like direct access to and from S3 from your game client, for example. You need some way to authenticate that. The federated auth is nice because you're actually offloading the authentication to Facebook and then say, OK, assuming that that user is authenticated to log in, then they're allowed to actually touch S3 as well. So that's all wrapped up into the login stage. So once you log in, then you're going to request some kind of matchmaking. There's going to be some logic that you have in your web tier where the guy says, hey, I want to play this type of game. And then your web tier would have a list of those servers running off to the right and be able to direct you one. So it's going to return a game server IP and say, OK, hey, for that game type, 4-person game, sniper rifles only, you want to connect to this button. There we go. You want to connect to this server cluster here. And then if it's a user-generated content heavy game, and before I gloss over details, sorry. So that connection, just to make sure we're clear, that would be a direct connection from the game client actually to your EC2 instance running Unreal or running a custom game server of your choice. You could run any kind of UDP or whatever layer you want to run across that. And that's enabled simply by giving a public IP and making sure that that security group is open to the internet on the applicable ports. And that's pretty straightforward. You can find that in our documentation. And if it's a user-generated content-heavy game, maybe it's a custom level. And you probably have to make a request to actually get assets. Maybe it's a custom map, or maybe it's, even if it's not user-generated, maybe it's a map pack, some kind of DLC. So you can make a request and actually get that from S3. I spent a little time on this step. So there's a couple different ways you can update your game content. One way is you can go through the App Store each time or go through the applicable PSN, what have you, to actually update your game. That works, and it's fine, but it does add quite a bit of lead time to your game, right? Best case, it's going to add a week or two or maybe even more, actually, when you're rolling out just a simple content update. And you think about time-limited content, in the simplest case, like a holiday level or something for Christmas, maybe you'll have enough lead time. But if you want to react to something, maybe you want to react to a meme that's in the internet, or if you want to just kind of do something zany to spice up your game, a 2-week lead time is a lot to deal with. So what a lot of game companies are doing is they're setting up their game so that when the game initially connects, it actually goes to S3 and says, OK, give me the latest set of files, and downloads those. And so in that case, what you can do is when you're actually updating your game content, it's just a matter of putting them on S3, putting your new assets on S3. And in the very simplest case, you can just put a little manifest text file or manifest XML file at the root of your S3 bucket. And your game client can just check that when it actually logs in. And maybe you would just have the list of files, and it would say, OK, I already have these, but I don't have these yet. And then make GET requests to pull down that content locally. So again, just to recap, so you would put your game assets in your S3 bucket, put a simple little manifest there, and then have your game client actually connect, read the manifest, and download any new content. Very easy workflow to let you really dynamically update your game. The other thing it solves is outside of getting title out to your game, it also solves removing content from your game. So I've got a game right now on my phone that my son really wanted to update because there was a Halloween level. He's really into Match 3. He's 4 right now. And so he thinks Match 3 is just like the coolest games ever. So there was a Halloween skin that was released for it. Downloaded that, installed it, and now it's March, and I still have the Halloween skin, right? Because I haven't actually gone and updated the app because there's not really any reason to. I mean, there's no reason to actually do the update. But if that was dynamically done, then the game could actually make that decision and said, hey, it's not Halloween anymore. Let's reskin it. Let's do something more interesting with it. You have a lot more control over that process. So how this ties into then the multiplayer scenario is you've got your game assets out there, either content that you're distributing or content other users are creating. Maybe you have a game that's allowing people to create custom maps or create custom levels. One of the games I worked on in the past, for example, we would actually let people create custom racetracks that they can then go kart racing around. And the cool thing about that was it was completely user-defined. We would let people upload them and share them, and we would allow people to invite people to join their other maps. And so by using this process, what you can do is you can actually enable that where users can actually create first-class maps as well. And by putting everybody through the same process of all your assets are living in S3 via CloudFront, then you can have one consistent process whether or not you're distributing content or whether or not others are creating content as well. So you pull down the assets. Other players join the game. You play along merrily. Game ends. And then in terms of your actual stats and stuff you want to save, you route those through your actual Elastic Load Balancer, through your Beanstalk tier, and away you go. So last few things we want to talk about here, actually running a little bit ahead of time, which is nice, and then we'll get to game analytics. So when you talk about scaling that tier, you've got two different directions. Scaling up is easy. Like if you think about, hey, how do we launch more game servers instances, you say, OK, well, scale up is easy because of the fact that we can just look at aggregate statistics. Say, hey, overall across all of our game servers, we're running out of slots. We're running out of CPU power, whatever the metrics. It's usually in terms of users, right? You know how many users can run 1632 on a given game server. So what you can do is you can report that metric to CloudWatch, our monitoring service, which is just another HTTP API endpoint, excuse me. And by reporting those metrics, you can actually then alert off those and set other actions. So you can actually say, hey, when the aggregate number of user slots available across all my game servers is less than 10 or 100, just depending on the scale of your game, then spin up a couple new ones that have Unreal Engine. You can specify the custom machine image, et cetera, and then away you go. So the scale up is relatively easy. The scale down is harder. And you guys, this will probably all be obvious to you, but you can't just yank an instance out from underneath somebody, which is the way a typical HTTP auto-scaling works, even in our auto-scaling. It just assumes all of your HTTP instances are all the same, so it just kind of treats them all as equally bootable and killable. But that's not the case with game servers, right? You have people connected to a specific game, to a specific server doing specific things. If you yank the server from under them, then they get very unhappy because they lose their game when they're 45 minutes into it. So you have to find a way to actually let those servers finish that. And currently, auto-scaling as is provided out of the box doesn't actually let you say, okay, well, wait for this server to finish it and then kill it. There's going to be continuous enhancements in that service, but right now, that's the kind of challenge. So when you think about it, you've got kind of two different flows, right? On up, you can think of the aggregate, but then on down, if you focus more on an individual server, and an individual server is kind of self-selecting and saying, you know what, I'm getting pretty bored. I can support 32 players, and I've only got 4 people on me. Maybe it's time for me to go away. It doesn't seem like I'm being very well utilized. So if you instead build the logic around individual server on the way down, it actually solves a lot of those problems. Because then you can have individual servers self-select and say, okay, it's time for me to go away. Don't send me any new connections. And then once that server, because it knows when its sessions are done, then it knows when its games are finished. Once its games are finished, it just shuts itself down. So how does that look graphically? So again, as I mentioned, on scale up, you can use CloudWatch. You can report a custom metric. For example, the aggregate number of slots you still have available. And as the server spins up then, you have to have some way for your actual Beanstalk app to know that it's there and available to use. One easy way is to just make another little JSON API. If you've already got that API layer, just make another easy JSON API call that just your servers call that just takes the IP or can figure it out from the request IP. Just takes the IP and says, OK, here's another game server. OK, this one's ready to go and able to help games. There's a little bit of security stuff, obviously, you have to do around that. You want to use HTTPS. It would be good also to make sure that the request is kind of coming from maybe a private IP address so that way you're not allowing arbitrary servers on the internet to connect and create game sessions. But then again, maybe you want to, right? Maybe you want to have a game where it can be crowdsourced and you can have people running games in the wild. And that, you would have that flexibility here. You could just make that decision. And then for repeating, it's the same thing over and over again. A new server comes up. It adds itself to the list. And now when a guy comes and says, hey, I want to play deathmatch, and the guy says, oh, deathmatch, OK, that's on this server over here. And then that previous flow we outlined, you can use that to actually get people onto servers. And then what about the scale down? Again, here right now, at least, this is not a place where CloudWatch really helps you, because CloudWatch just looks at aggregate metrics. So CloudWatch only looks at stuff for auto-scaling purposes that is actually across your whole fleet. And here what we want to do is we want to have servers be able to say, hey, I'm actually bored. It's time for me to go away. So one easy way to approach that is to say, OK, when a server decides, hey, I've got 1 game. I can host 10 games on me. I've only got 1 game running. So I'm going to assume that I'm one of the least utilized people. It can basically just set a grace period and say, OK, I'm not going to accept any new connections. Wait for those connections to terminate. And then when it actually ends the session, it can just send another request to your server, similar to the registration request. Now it sends a server request and says, hey, deregister me. I'm going away. Don't send anybody else my way. It's not interesting. I'm going away. As I said, refuse new connections. Click button. All right, cool. And then once it gets a response saying, OK, deregistration was OK, waits for the game end, and it halts itself. So one interesting implication of this approach, or one kind of nice thing about this, is that it enables you to view your different game servers as really autonomous entities. When you're thinking about distributed architectures, not to wind up too much in the clouds, excuse the pun, but when you think about distributed architectures, the more you can have things kind of operating independently and interacting, the more you're going to be able to just kind of keep scaling. Wherever you have single points that are actually trying to orchestrate multiple things in a top-down fashion, those tend to be your bottlenecks. So the nice thing about this approach, by having servers just kind of spin up and say, hey, I'm ready, OK, hey, I'm going back down, is it enables you to scale up whether or not you've got 10 users, 10,000, 100,000, et cetera. You can keep that same pattern as you keep growing. And this actually becomes particularly beneficial when we talk about multi-region. We talk about, OK, glossed over in one of the first slides, like, OK, your game's great, and going global is important. So what does that actually look like? Well, you start out in somewhere, say, the East Coast, West Coast US, and you build your app out here, and it's got your game servers all set up. And then it turns out your game's really big in Tokyo, and everybody's talking about it. So you say, hey, well, there's a region in Tokyo. We should take advantage, see if we can actually capitalize on this. But don't want to build out this whole giant infrastructure. All I care about is making sure that the latency to the game players is actually as low as possible. So you can pursue the same model then. Have your EC2 instances there. Again, It's the same API, so you can have the same model that you actually used on your servers you already have in Virginia, have them spit up, register with the central server in the same way, have them register central server same way. And I didn't draw it on here, but when you have your actual users connect to your Beanstalk app, then they can just provide regional information. They can just say, hey, I'm coming from the US, give me the server in the US, or I'm coming from Japan, give me a server in Japan. So side note on that, there's some fancy things you can do where you can use Route 53, which is our DNS service. And it has some pretty cool stuff you can do, like latency-based routing. So you can make this completely automated to the point where you could actually say, hey, based on the latency where a person is coming in, connect them to the applicable game servers that are closest to them. Perfectly valid approach. Thing to keep in mind, though, is that if you automate this process, there's a lot of people that are going to be awake at 3 a.m. and know that nobody else is playing near to them, and they're willing to deal with a bit of latency. They'll connect across the ocean. They're fine with that. So if you're going to automate it, make sure you allow a way for a person to actually select it. So that's why when I outlined it here, I think low-hanging fruit in terms of something that works consistently is just have your game client actually know where it's connecting from. That's easy. You can just put that in the app and say, OK, I'm connecting from Japan. So by default, I'm going to go to Japan. But you probably also want a little menu in there somewhere where the person is allowed to select another region. And they can say, OK, instead I actually want to play in the US. And then it can just make a request to the same Beanstalk layer using that same API you've built and said, OK, hey, US, please. And this is, hey, you're in luck. I've got servers over here for you. Does that make sense? So you're kind of viewing it more as a default. And again, takeaway point being is that the more you can use kind of the same set of APIs and kind of keep each layer simple and a little bit independent, then the more you can kind of combine these in interesting ways. And with AWS as a whole, that's one of the things that I particularly find interesting is that all of our different services are available a la carte, which at times can make it seem overwhelming because we've got 35 different services nowadays, and you're kind of like not know where to start at times. But what that enables you to do is it enables you to put these pieces together. You don't wind up in a situation where you're like, oh, well, in order to do this, I have to use these 6 other things and then tie them all together, and now I have to build this whole ginormous pipeline just in order to get this one simple thing done. All right. I think we're going to wind up a little bit on time, so we can have some, or a little bit early, so we can have some coffee. I'm going to talk a little bit about messages and queuing. I'm not going to spend a lot of time on this because actually, after my next talk on analytics, there's going to be a full hour where John Turo, who's our senior PM for our actual mobile push notification services, is going to go into detail about all the cool stuff you can do with push messages, et cetera. I have a couple slides just for the purposes of showing how it integrates with all the stuff that I've outlined so far. So I just wanted to add that just as kind of context, so when John's talking later in an hour or so, you can say, oh, OK, this is the part he was talking about, and then that would click into the app in this way. So our simple notification service is the basis of a lot of things. I think of it as kind of a transport for delivering messages, for lack of a better term. It's got a couple different types of endpoints. It's got HTTP, SMS, and mobile push. Mobile push meaning the ability to actually send it to iOS, Android, et cetera devices. But from your app, it actually just looks like a common API endpoint, similar to our other services. So what that means is you can run it alongside your app, and you can actually have your app send SMS messages based on events. So maybe we're playing the game together, and maybe we're friends on the same friend list, and I one-up you. You can have your app say, oh, OK, if your friend beats you, then send a notification and say, hey, Nate just beat you. Why don't you jump in the game right now and see if you can beat his score? So by using the HTTP endpoint, you can actually have your app server tier just send those messages automatically. And again, I'm not going to spend time on all the details because John's going to cover that. Another service which I briefly mentioned, which is CloudWatch, which is our monitoring service. This kind of sits outside and is again, it's an API endpoint where we have a lot of stuff we automatically put in there for you. We have EC2 instances that spin up, and they report stuff. When you spin up a database, in Dynamo, et cetera, it will actually automatically report stuff to CloudWatch. And out of CloudWatch, you can actually do not only alerts and stuff and custom metrics, but you can actually create some workflows, which I'm going to talk about very briefly. And so one of them is you can actually get an alert, and you can have it report to SNS. And what that lets you do is from SNS, you can then route it to multiple places. So in this case, you can send it to the cell phone and says, uh-oh, looks like the servers are melting. I guess I better head to the pub. So hopefully you have a better plan than that, but you get the point. Although the pub might be a nice place to be right about then. So take a side topic, and then we're going to come back to that example. So another complementary technology we have is SQS. This is one of the very first services we launched in 2006 or so. And it's our simple queuing service. You've probably heard about it if you've seen our website at all. And it's just the simplest thing you can imagine. You put a message into this, and then on the other end, you have another machine that can just pop messages off, and different machines just pop messages, and messages pop on, pop, push, you get the idea. The use cases that are good for that is anything that you don't want your front-end servers to actually do in real time. There's a whole lot of stuff. User-generated content has like 20 examples I can think of off the top of my head. A person uploads a new piece of content, a new level they created. You don't want your actual game server, or your web tier that is doing all that real-time traffic to be sitting there spitting out little thumbnails, spitting out stuff that can be linked, spitting out permalinks. You don't want that to happen. It's not a supportable approach long term. So what you do in that case is you have the client send the file to S3, as we outlined earlier, and then you just put a message in SQS saying, hey, new file. Somebody needs to deal with this and do the appropriate stuff. And so what that looks like is you can actually have SQS, and you can have these back-end EC2 instances. Again, you can just spin up another group of EC2 instances, listen to the queue. And that's where you pop that message. So avatar resizing, even score processing. If you're doing a top end leaderboard, top 100 people globally, which is still interesting, not as interesting as friends leaderboards and stuff, or geographic leaderboards, which are my personal favorite right now, is if you're doing your top 100, though, you don't want to recalculate that every time you have a player post a score. That would be ridiculous. So you really want to only say, OK, this guy had a likelihood that he was near the top 100, so why don't we check? And then you can pop a message in there and say, OK, recalculate that leaderboard. Otherwise, there's just so much churn, you're just going to eat up your database layer. So that's another example of stuff you can do via this approach. Click. All right. And the other cool thing about the SNS is the fact that because it's just an API endpoint, you can have any of your different EC2 instances actually address it. So you do that background processing for Leaderboard. It gets that message, a resource to Leaderboard, and says, hey, you know what? You're in the top 100. Like, let's send this guy a notification saying, hey, congratulations, you're in the top 100. Sends it back to the mobile device. It's an interesting way for engagement. Again, not going to spend a lot of time on that because John and Mike are going to talk a lot about interesting ways to use that in the game. But that's the technical workflow of how it works with the other server components that you've deployed so far. So last point on messages. So you've got CloudWatch, which we already talked about. You can have it send to SNS. SNS actually connects to SQS as well. You can kind of interconnect these things in different ways. So you can actually have SQS listen for a message from SNS. And you can have your actual background server do something. Maybe that's spin up another game server or do some other process additional stuff out of a queue. And then it can send you a message because you'll already be at the pub relaxing and enjoying your success and basking in glory and all that. So that's the extent of messages that I want to talk about, but I just wanted to settle on this for a second. This is kind of your complete workflow if you're going to use SNS and SQS. This is how they interact with the other services we already built out. So when you're talking about, when you're listening to John's talk a little bit later when he goes all the interesting stuff with engagement, just kind of keep this in the back of your mind. He's probably going to have some slides along these lines as well. And you can kind of just think of how these can start connecting together. All right, so we are a little bit early, which is great, because I need some coffee. Few last just takeaways. So start simple with Beanstalk. As I mentioned, do as much stuff as you can in the HTTP layer. You're going to be happier long term. There's a lot of stuff, lists, game lists, joins, friends lists, et cetera, that are particularly well suited to it. And I would say that if you have the time, don't go down the traditional database path if you can avoid it. MySQL is really easy. SQL Server, everybody's used to it. You got it on your desktop. You can run SQL commands. It's just the simplest thing to get started with. Spend a couple hours tinkering around with DynamoDB. See how you like it. We've got a lot of mobile game companies that have gone down the path. And as I mentioned, Halfbrick is a great example. They did a post with Werner, our CTO, on his blog. Basically went over and said, hey, we went down the relational database path, totally just ate our database alive. We were basically crippled, moved over to DynamoDB, and now we couldn't be happier. And that's pretty consistent. We see that pretty consistently with game developers. As I mentioned, CloudFront, our CDN, plus S3, our object store for both download and upload. Upload's a pretty interesting use case. It's kind of unique to CloudFront. So maybe get your wheels turning on things you can use for that. And then when you actually talk about multiplayer game servers, that's that hybrid approach we outlined where you have your Beanstalk app and you just keep expanding out, add your multiplayer servers. Use the EC2, C3 instance. It's totally awesome. Honestly, I think it's just the coolest thing since sliced bread, so make sure to use it. You can use it for stuff more than game player servers, too. It's very aggressively priced. So if you look at actually the pricing, it's very popular right now. It's huge in demand because a lot of people are like, why wouldn't I just run this for everything? So definitely check it out. We've got a whole bunch of sizes from large up to 8XL. And then finally, SQS to decouple and scale out your architecture. All right, so that's it for this part of the talk. So I guess we're about 15 minutes early, so we can take a break. And quick note I'll mention, at the bottom, that AWS Game Dev, that actually comes to me and a couple other people on my team. We have a small team, I forgot to mention that, of just people that work with gaming developers. That's all I do. That's all the people that are on my team do. We just work with game developers worldwide. So if you're a game developer, as you guys are, and you have any questions, use that email alias. It'll come to us. We can help find the right place to go. Or if you want to see me on Twitter, that's the other thing there. And then for each different topic, each different talk today, we're actually going to have a different URL here. So if you thought this was a great talk, please use that URL. If you thought it was terrible, use a different URL. So, but the idea is you'll actually get entered into a Kindle HDX as well. So, cool.
Super.
Cool. Thanks, guys.
No, it's okay.
Yeah.
It's okay.
What's up, dude?